Generally, I think, many people have realized that multi-agent systems have been really powerful for a lot of these read-only research workflows. And today I'm really excited to bring in Walden, the co-founder and CPO of Cognition, to talk about why we don't do that for multi-agents in the coding context. Today he'll talk a little bit about how the frameworks we're thinking about are pretty premature and his two core design principles around traces and avoiding multiple components. And then we'll talk a little bit more about how single agents scale out and how they can even use read-only subagents to get a little bit more context. As always, any questions you have will be posted in the Slido. You can go there and upvote them. And with that, Walden, take it away.
Yeah, thank you, Jason, for having me. And, I'm really excited to be talking with everyone here about kind of like this thing that we've been thinking about a lot, whether we want it or not, when building Devin, which is just like, how should we think about what kinds of patterns in agent building are robust and what kinds of patterns aren't robust? So, a lot of this is going to be covering the ideas I go over in a blog post we made a few weeks ago. It was called "Don't Build Multi-Agents." I think that if there weren't the goal of like making the title something that people would be excited to click on, I think maybe like a more appropriate or just like general like high level title would be something around just the idea of context engineering. And the reason I say this is because a lot of the reason why we suggest to not build multi-agents is ultimately coming down to how you think about context and the difficulties of moving context around multi-agents. I think another blog post, literally the day after, came out from Anthropic about how they build multi-agents. And this is just something I really want to touch on because the funny thing is, if you go through and read the blog post we put out and read the blog post that Anthropic put out, a lot of the ideas in the blog post are actually very similar. We both talk about the importance of moving context, where you have to be very careful in constructing your systems and prompts in order to get things right, even though the final titles seem like they're contradictory. So in this case, I want to I'm going to spend most of the context of this conversation talking about the theory of context engineering and less about this ultimate conclusion of like whether you should build multi-agents or not, because it does start to depend on the context of what you're doing. But at least in the coding context and what we do building Devin and Cognition, a lot of the multi-agent systems we've played with can be quite fragile. We've ultimately moved away from, but in other domains it might be interesting. Just to give some quick filler on what context engineering is and why you should be thinking about it. I think there's kind of this like mimetic terminology of like prompt engineering going around right around like when ChatGPT came out. And on one hand, it was fun because it was this idea that hey, like you could talk about like you know you tell your agent or you tell your there weren't agents at the time. You tell your chatbot, hey, pretend you're like a 99 percentile writer, or 99 percentile coder, and there are all these tricks like saying you would tip the agent and how that would like improve its probability of doing things well. And I think we've moved away from that world. Largely, models today are generally very good and very smart, and the labs have already done all the work of like making sure you don't have to type out all of this unnecessary stuff about pretending and role playing like how smart or intelligent you are. And now the only thing that is really standing between how intelligent these systems are and how much useful work they can do for you is how much context do they have? How much do they know about what you're trying to get them to do? How much do they remember about what they have done for you already, et cetera, et cetera. And this is really the number one priority if you're building agents, is thinking about how do you get the context of what it has to do and what it has done to the agent at every point in time as it's making decisions. So I like to make this analogy about the early web and the arrival of React. React is just like so widespread today, and in large part because of LLMs. But React is not how the web was first developed, and in some ways it's almost like unintuitive when you're first learning how to use React. But the big difference that React made was that it kind of builds in to itself all of the core principles and ideas of web development that are needed to make a website feel good. In particular, the ability of like a website to be like very dynamic and reactive, the ability to make sure state is maintained and consistent through like these hooks and patterns. And that was like, you could do that with HTML and JavaScript and CSS. React didn't make website building, it didn't unlock things that weren't possible before. It just codified it so that it was really easy to continue to make sites that follow these great patterns. And so there are a lot of people who actually try to make LLM frameworks today. And I almost feel like it's too early for that, specifically because we are in this age of basically the equivalent of HTML, JavaScript, and CSS for building agents and building LLM systems. We're still learning a lot of what the important principles and ideas are going to be. And eventually we'll probably get to the point where we have great frameworks where you can kind of skip all of this like hard learning and just get straight to like building systems that are like perfectly optimized and use all the right patterns. So this is, I also think, why it's important to be thinking about and putting words to the concepts and ideas that people who are building agents just end up finding ourselves relearning over and over again. And yeah, the context engineering and context passing is kind of one of these key things that I'll be talking about today. I'm just gonna. I want to walk through and motivate context engineering and these ideas about context passing with just a kind of exercise of like, imagine we're building an agent and we want this agent to kind of like be powerful and do some multi-agent stuff. So I kind of put a diagram here of like how you might build, your first attempt at like a multi-agent system. So let's say you have a task. Maybe you'll give it to one agent or one LLM to take this task and split it into multiple parts. So it'll take your one task and it'll decide, okay, like it seems like there's these two subtasks. It'll give these two subtasks then to other agents. So that way these two sub-agents can do their work in parallel. And then let's say these two sub-agents, their final results are then taken, given back to one final agent to combine the results. And this pipeline is going to be the agent that we're looking at. So let's run through an example. Imagine we give the task of building a simple clone of Flappy Bird. Well, you might have one subtask be, okay, let's build the background with the green pipes and hitboxes, and one agent will go do that. Another agent, you'll kind of make sure you have the bird asset and that can move up and down. Well, what'll happen is if you're not careful, you might end up getting like, one agent interpreting like a background with green pipes and hitboxes to be something closer to Mario, because Mario has like green pipes that has a moving background. And then you just told it to build a bird that can move up and down. There wasn't really much context on what this bird should look like or what else it is, and you might actually get a bird from a completely different game. And then now you're giving your final agent two completely separate assets that aren't really coherent with each other and don't actually like have the mechanics that you want either. So this is not great, and it might feel a bit extreme, and I'm purposely kind of like exaggerating how bad it can get here because it is a simple example. In reality, this will like kind of work for Flappy Bird if I had to guess. But the context you should remember is that Flappy Bird is just like a very simple example of a task. If you take this system and are running it in production on like even thousands, certainly this becomes an issue when you're getting to like tens of thousands of tasks, and these tasks are relatively complicated, you're going to find lots of places where miscommunications like this are just going to get introduced in your system, especially as when the user is talking with the system back and forth many times, when these sub-agents are getting more and more nuanced tasks and you forget to pass some details through. Those are all like kind of like areas where the system can break down. So this Flappy Bird kind of miscommunication here is just kind of illustrative, but it is something that really happens when you take any of these systems and try to run them at scale. So the way I propose you have to try to get around this is, in our case, these subagents, they were only understanding what they were told by the main agent. And you're playing this game of telephone where like you're telling the main agent to, hey, like, can you just like take what you were told and then break down a version of that to be told to the subagents. What you really want is to minimize this game of telephone. So how can we let the subagents directly see what the main agent saw so that they have the exact same, if not better context than the main agent? And more so than that, one other caveat as you're building real systems is the context isn't just the user message that came in and the task that it's been given, but it is also the context of everything that you have done as the agent. Like if you as the main agent have looked at code files, if you as the main agent asked questions and got answers to those questions, that context, those full agent traces should also be given as context. So not just the user message, but also the full traces. And all of this context is ideally things that you should be passing around to the agents, to the LLM calls in your system. So here's a version of what this might look like. In this case, I'm using these kind of colored squares to represent context. So basically the original green agent, the original agent we had for breaking down the task, it can see its own context about the conversation it's had with the user and anything it's done to decide how to break down the code. Subagent 1 and Subagent 2, they actually see the same exact green context. So the same exact set of messages and actions that the original agent took when they are working. And they, of course, also see the context of their own work. So Subagent 1 will kind of see the context of all Subagent 1's work. Subagent 2 will see all the context of Subagent 2's work. And then importantly, the final agent, and this can also be sometimes tricky, is something that is capable of seeing everything that happened with the original agent and conversation, everything that Subagent 1 and Subagent 2 did, and then it is also has the context of what it is doing to combine all of their work together. So the passing of the green context in particular here is what we're going to do to kind of avoid that problem of Subagent 1 to Subagent 2 not understanding the original task. So okay, let's take this for a spin and see how this does in the Flappy Bird task. So you give the Flappy Bird task, we still have like the things to do on the left and right. It's better for sure. The thing is, Subagent 1 and Subagent 2 aren't communicating with each other. They don't have each other's context. So what you might get is you might get a nice like set of green hip pipes and hitboxes, and you might get a bird that can move up or down. But there's lots of different ways in which, there's lots of different ways in which the thing that Subagent 1 does and the thing that Subagent 2 does, they might be different styles from each other. That's what I'm choosing to illustrate here is the bird is at a different artistic style from the pipes. At the code level, they might be using different APIs from each other. They might re-implement some same code. They might be incompatible in other ways. So having these two subagents that can't talk to each other, it's like having like a team of engineers where like you can't let them message each other. They're gonna end up stepping on each other's toes if you're not careful. And so again, you might result in a conflict, or you might just end up with a poor result. So if we really reflect on what's happening here, basically like it is the true that Subagent 1, Subagent 2 understood what the original task was. They understood the mission. The thing is, Subagent 1, Subagent 2, they started doing things, and those doing things are basically committal. And when Subagent 1 is committing to certain types of work and certain types of decisions, and Subagent 2 is also committing to other decisions. These commitments and decisions conflict with each other. So with any agentic system, lots of actions can basically carry these implicit decisions being made. It might feel like, oh, I'm just following orders, but there's a lot of implicit decisions, from like the styling to like the way you choose to build your variables. And anytime these decisions are made, you almost always have to actually make sure this decision is shared with everyone else, or else you might just get these conflicting decisions and you can get really bad results from that. So if we think about the principles we built up so far, the first one of let's just make sure we always share context and share the full agent traces of context. And principle 2 now of, hey, let's make sure that decisions are something to track very carefully and make sure we don't step on each other's toes. What is a system we can build that is relatively reliable? So the most simple answer is just do like a linear simple agent where, you can still have your agent that breaks down the task, but let's not run subagent 1 and subagent 2 in parallel. Let's just give the task to subagent 1. It'll do the first part of the task. It'll have the context of everything that happened before. You go to subagent 2. It does its part of the task. It has the context of everything that happened before. And then finally, you have the final agent that's combining their results. And that final agent has the context of everything that has happened before. So the nice benefit of this thing is there are not multiple decision makers at any given point in time. Subagent 2 is already living with the decisions of subagent 1, and it has the context of what subagent 1 does. So it knows what subagent 1 has decided on. It can work off of those changes without stepping on subagent 1's toes. And then the final agent, again, sees everything that happened, and so it can combine the results in a nice way. Now, this is possibly like the very first thing you would build as an agent builder. It's just like the simple while loop of a system that just does things and maybe have some task breakdown at the beginning. And yeah, it works. It really quickly runs into limits though. And this is kind of where you are really trying to add value as a context engineer, is what are the limits of these systems? And so the simple system we just looked at, LLMs have context windows. And even before you hit their context windows, they kind of start making bad decisions the more context you feed into them. So you probably will have some implicit limit you want on like how many tokens you want to have and give to your model before you want to start condensing what information it has. And so with a simple agent, if you're just collecting everything that this agent's been doing, and especially for these longer tasks, you'll quickly run into context overflow issues, especially as you go down the line towards the end of your task. And so that's not very good. We said context passing is important. How do you get around this? There's a lot of different ways to do this. This is probably where like you kind of have to be creative as an agent builder. The thing I will be talking about today is at least an idea we explored and was what we did very early on at Cognition, was think about, okay, if we're passing context through, can we be intelligent about what context we choose to pass from one agent to the next? And so we built this system that we basically think about as the context compressor. And every single time we have some context from a previous part of the system, we'd pass it through this context compressor, and then we'd have a shorter version that we can give to the next agent. And the idea is because these systems are getting, or these contexts are getting shorter as we're passing it on, you don't run into this context overflow issue as easily. Now, this system also has its limits because eventually even these short pieces of context will overflow and you'll have the same problem again, but you can get a lot further. I will say this context compression LLM, it is like this one simple thing you add to the system, but it ends up adding a lot of complexity and is very hard to get right. You have to think very hard about what are the things specific to your domain, in our case, coding, that is actually important to carry from each step to the next. Because if you don't think really hard about this, you're going to run to the same problem we had at the very beginning, which is important details, important decisions, kind of just getting lost as the agent works. In our case, actually, one thing we did is we actually trained a model to get really good at taking pieces from earlier pieces of conversation and moving that into the next part of the system. And we have other advanced parts of this thing today. I would say that you have to think very carefully about, are you willing to put in the work to kind of squeeze out this extra juice from your system? In our case, it makes sense because our entire goal is to make sure that we can take on harder and harder engineering tasks. And for us, the investment into this system makes sense. But we are also very careful of not having too many things like this because, again, it adds complexity. It is something you have to be very careful of, and it takes real engineering effort to get right. A lot of trial and error, and you have to build out a lot of evals and a really good system to test these kinds of things. we talked at a high level about context engineering. I want to just give some like really quick real world examples about agents people have built and how they think about context engineering. So one is this idea of a read-only subagent. OpenCode, this is literally a tweet from yesterday, so it's really relevant for this talk. But also, Claude Code does this. The idea here is that, okay, if conflicting decisions is a lot of the root cause of where issues come from, what if you don't have your agents make any decisions? All they do is just try to read and find stuff for you, and then they'll just like aggregate that into one final thing. So Claude Code does this. I think in Claude's multi-agent blog post, they talk about a system that can like research a lot of websites at one time. OpenTool, they talk about, yeah, the task tool is the subagent tool. And if you look at the tasks that the subagent is doing for OpenCode, one is like just listing the project files. One is just like looking at some packages. One is just like looking for some imports. These are all reading tasks. And reading tasks are really not as bad, but also in particular, the designers of these systems, these agent builders, are very careful to constrain their subagents to only doing read-only tasks. I think if you read the Claude sys prompt, if you read OpenCode sys prompt, you'll probably find stuff that's like you should only use subagents for things that involve reading code. Because as soon as you have it writing code, oh man, now you have stuff happening in the background and it's hidden, and you don't know what's happening. You also see that the author here is talking about saving context window. And so in this case, read-only subagents, the idea of having a system that isn't going to be making decisions, that only has like one kind of like final result to share with you, maybe that final result is actually the only thing that's relevant from what the agent has done. Again, there are cases where this breaks down, but it is at least a heuristic that is kind of like well thought through, and they understand the trade-off they're making, which is you're saving context window for the trade-off of maybe taking on like 1% more risk in the subagent, giving you some incorrect information. For what it's worth, we've also seen subagents, even read-only subagents, go wrong before. One simple example is you have two read-only subagents. You tell them to look for different things. They come back to you with answers, but these answers actually conflict with each other on how they claim the underlying system works. Like, what do you do now? Because now you don't have the context of either of these subagents. You don't have one thing that's deciding who is right and who's wrong, and you can run into some of these problems again. So you got to be careful. Another one I'll quickly go through. This is a funny thing. So it exists in many systems today, including Cursor and Windsurf. And it's this idea of an edit apply model. The rough history of this, and by the way, edit apply models, I think is just like a really interesting kind of like look into how you can really squeeze out juice of a system when you own the underlying inference for your LLMs. But that core idea of edit apply model is that at one point models were really bad at outputting diffs. So they were really bad at editing code, but they're really good at spitting out basically chunks of markdown explaining to a human what code should be changed. So we would have this thing where you take a really smart coding model, it would output the instructions for that is usually for a human to read about, oh, like, change these parts of the code, or like leave some comments about like, oh, delete this code here. And you take your edit apply model, and this LLM's entire job is to take the human readable instructions from this agent, take the original code, and then just spit out the new final version of the code. This edit apply model is built to be a very fast system. So it can go from the original code to the final code very quickly, but it's also not a very smart agent. So the smart coding agent has to give very, very clear instructions to the edit apply model about what to change. And here is exactly where you can start having some breakdown in your system's accuracy, because you're doing this context passing. The apply model here, the thing it lacks isn't necessarily context. It lacks the intelligence of the smart coding model. So the instruction passing here is basically the entirety, is like the main bottleneck in the system of how accurate will the final edit be. And I think, when you see complaints online about, hey, sometimes in these code editors, the edit will be like wrong and it'll mess something up, it is often because of this, that the smart coding agent left out some important detail or wasn't specific enough about something, and bam, the edit apply model, did something wrong. this is kind of an example of like fragility in one of these systems. And yeah, to quickly just get back to like the original point in question from the beginning. So multi-agents, as they've generally been explored, I think in just like the general popular tech culture, is this idea of just like almost having like an entire company where every single role in person is replaced by an agent and having them collaborate with each other. That world is, I think, a world that like that we're not really ready for yet. I think if your multi-agents are very constrained, like maybe for these read-only use cases, they're passable. You just have to be careful. You can't avoid the problem of doing context engineering. Anthropic in their blog post, I think, talks a great length about how they prompt their subagents or prompt their agent to only use their subagent in very specific ways, or else you can get things that go very wrong. And I also just generally think that if you're abiding by like kind of principles of good context engineering, your system as a whole, even if it has like subparts and tasks, it kind of should feel to the user like a single agent, because the user has to feel like they're talking with one continuous decision maker, one continuous like consciousness almost, even if there's like a lot of underlying things happening under the hood. So when we build Devin, we always try to build it such that it feels like one entity that you're talking to. And then the other thing I think is that we'll eventually get to the point where you have multiple LLM agents and they're working with each other on a team like coworkers, but it actually requires being very intelligent to be good at collaborating with other people. Like when I'm working with another engineer on my team, if I am mentally modeling at the same time what they know, what they don't understand, and what I have to tell them. So unless these LLMs basically get really good themselves and get really intelligent themselves, that is going to be the bottleneck to getting at these multi-agent systems work. But once you get good single agent systems, once you get a single agent that is good with interacting with a user and make that smarter and more collaborative, then we'll probably unlock the agent to agent, multi-agent world naturally. But the single agent world is kind of like really where I think this space should be focusing, getting to progress. And then we'll get those multi-agents that were promised. So yep, that's I think that's my time, and that's the general gist of my talk. Again, thanks for having me, and I'm very happy to kind of like go into questions about this, or just generally questions about cognition.
I think there's a bunch of really interesting questions here, so let's just jump in real quick. Yeah, I mean, one of the things you talked about was just sort of how much more intelligent you have to be to collaborate as software developers. Do you have a sense of like what are these specific skills that these agents are lacking? Is it like the ability to interrupt? Is it making pull requests and reviewing PRs? I'm curious, like where do you think this lack of intelligence and collaboration is coming from right now?
Yeah, there's a lot of things here, and this is probably some of the things we are thinking about most as we are going to the realm of like human agent collaboration. So one thing I'll say is that for most people, human in the loop means like there's a system and you can like press stop, or you can press go at any point in time. You can interrupt it. It's really nice. It gives you a lot of control as a developer. What do you think about collaboration, where like you're working with an entity that can run for long periods of time? You don't want to take the human out of the loop. The human has to be the ultimate decision maker and will approve anything that is done. But the agent almost has to be more intelligent about how it interacts with you. And so one thing that systems are not great at today, and one thing that we work on a lot, is this problem of escalation, right? When can a system recognize when it reaches its own limits of the decisions it is allowed to make? Okay, like, you're working a task. Turns out there's some really niche problem here that you didn't expect at the start when you talked with a human. And it requires actually a pretty difficult architectural decision. How do you know, like, either way, you should notify the human that like, hey, there's something weird that's happening here. The changes are not going to look like what we originally expected, but maybe it actually has to be the human's decision. So escalating decisions and being good at noticing when something is out of your depths is something these agents aren't good at yet, but it's going to be a very important part of getting this right. This is also very closely related to confidence, like how confident is an agent in its own decisions. And so in Devin, one thing we do is when you're collaborating with your agent, when you're collaborating with Devin will give you how confident it is in its plan. And that way, you as a human can say like, oh, okay, Devin is like 99% confident that this is going to work. You can roughly be hands off. You can just come back to your PR later. If Devin's only like 60% confident, like, okay, let me see like what it wrote down for you. And then there's also this problem that comes with that of not being verbose. I think people hate how like, LLMs will just send you like a wall of text in Markdown. A smart engineer will like manage to hone in on the key problems and the key things you have to think about with like minimal words. One sentence, two sentence of words. And that's what we try to also do with Devin is like, can we just minimize the amount of words we need to like get the human on the same page as the agent?
Mm-hmm. And are these systems mostly prompted now, or you mentioned training your own models for things like context compression? Yeah, like has it been the case that these newer models are just intelligent enough to do this, or have you had to sort of like use Devin as a harness to sort of collect this feedback data?
Yeah, I think that's absolutely the right question, and it gets into territory where I can't fully talk about the exact
Sure.
details of everything that we do. But I will say that, like in many of these cases, it isn't within like the capabilities of the main agent, and so you do have to kind of like find either like prompt really really hard, do things like case shot, at times fine tuning to get the capabilities that you want. And sometimes there's like ideas which like you just have to put on the boilerplate or put in the on the back burner until some system does come along that's intelligent enough.
That makes sense. Do you guys just have like a set of evals that are like failing today, and every time a new model comes up, you just rerun it and then decide whether it's worth
We
pursuing?
have lots of evals here. Yeah, it is like one of the key things. You also realize that eventually, as you scale an org, like you can't just like do everything through travel knowledge and remembering like what was working, what isn't working. You kind of need evals so people will have a like a concrete way to know like, hey, is something better than it was before.
Yeah, I saw some videos a while ago about like YC companies like, oh, we are scoring 100% on your evals. And like that's like the success metric. And it's like, no. You want evals that are failing so you know when new models come out, you're going in the right direction. Um, I mean, given that, I guess now it's probably just the case that like this context compression, like that is just something that is happening at every single like agent pass, or is it now very much like some of the other systems? I think like when I see like AMP and Claude Code, it just says, if I'm running out of context, I will like compress my context. Um,
Mhm. Yeah, so AMP and Claude Code, I think the model they follow is something like when you reach some part of the limit, you do some compression. And I think that that's very reasonable as well. In many cases, again, you have to be very careful about how you prompt the system to compress and what information it should keep and what information it shouldn't keep. I think that's mainly probably like the biggest area of difference in any of these systems is just like how they're deciding what context they're surfacing to their agent at any point in time.
yeah, you definitely have to sort of know what the goal of these systems are. I think in the coding context, it's very clear of like, okay, know what files have been changed, where are the tests, how do you run the tests? But I think in a lot of other contexts, it's been hard for people to sort of reason about these kinds of tools. Um, I guess one question I also have here, it's like, where do you think all this like multi-agent stuff and this context passing, where does that fit in with like the bitter lesson? Like in my mind, and I'm very biased here, I feel like in the future, it will just be one agent, right? Or do you think there's actually mechanical benefits that we can't realize with multi-agents,
Yeah, I kind of think I agree with you, and it's related to what I was saying on this last slide, which is like a well-engineered system and agent, even if it's very complex and has lots of moving parts, should feel like a single agent. I think a lot of movies, like the
Yeah.
AGI that they build, like you can talk to it like a person, even though there's probably a lot of stuff going on in there. Um, how it fits in with the bitter lesson, I think that's like a very interesting question. I think another benefit of like single agent systems is you can I think generally be like smarter about how you scale them, and it's like kind of like it's a simpler system for you to work with and go through. And this goes back to this idea of like you really are making a trade-off anytime you introduce complexity to eke out accuracy. And you better make sure that complexity isn't like reducing your reliability of the system.
Yeah, I think that's another question that people tend to ask me in particular. Okay, like should I do this technique or that technique? And it's always going to be more about the budget, right? It's like if this more complex feature gets you 1% improvement, it might actually not be worth it based off the latency or the cost or anything like that. Um, And I'm sure you just have a bunch of evals there to make sense of it all. Yeah, and I guess in these contexts, I guess a single agent is also probably easier to train, right? Or has it been the case that like multi-agents, I don't know if there's been any big difference in the way we have to train these things or think about few shotting.
Yeah. I think single agents are not only easier to train. I mean, it's also just generally where most of like the research work goes. I think because multi agents as well, for all the reasons I mentioned, are also just kind of somewhat unreliable. And when you're a researcher, you kind of want to make sure like the only reason your like evals and scores are low is because yeah, you got to keep training, you got to add more data, not because you like your agents played some game of telephone that wasn't working correctly. Although that's going to be something that again, all these ideas about agents getting better communication and passing context is going to be something that will have to become part of the training data, and some of these agents will get better at.
That makes sense. Yeah, one thing I also noticed was when I've been using like coding tools, I generally have like a very weak form of a plan. It's just like you read some documents, make a plan file, and then try to do it. Recently, I've been watching some like pretty intense like coders, and they'll spend like 30 minutes, 40 minutes building out this like massive plan MD file. Like, what has been the work on like planning in general, right? You can imagine maybe there's a world where I define an API layer and I have two agents that work on the back end and the front end, and we just guarantee that like this is the standard API that exists there. Do you think there are specific kinds of work that multi-agents could be useful for? I mean, maybe not in the generic case, but
Yeah, so planning is something that we do, and the context of planning originally came up for us as actually a form of context management because again, it's about avoiding this game of telephone where you have to like constantly recompress and the information that you're sending to your agent. It's about committing to what you're doing up front and then letting the agent kind of follow that structure. And
Mhm.
so planning is also this nice read-only space where you can get to do your own thing. So at the very start of any task, when you give it to Devin, Devin's gonna spend time reading a lot of code and generating a plan, often doing a mix of lots of systems. And maybe that is like probably the one place where we do think about some of these like sub agents or multi-agents, if you will. Although we don't really think about it that way because again, Devin is built to kind of feel like the single thing. Um,
Mhm.
I think planning is going to be a super powerful thing. I think that going the full plan MD route is like one of the ways you can put in more effort and get better results in the end. Although I also think that these things will become parts of the systems themselves, and that's where we're trying to kind of go with Devin. Is like, hey, you can be shown the plan. You can click this button to like view the full plan that the agent's working on, but the agent will work on this internally for its own sake.
Yeah.
Whether or not like you tell it to or not.
Yeah, that makes sense. I've had plans now where it's like phases like 1 to 3. Each phase has like the files you're allowed to update, the tests you have to run before they pass, and then like the port PRs you have to make here. Um, I mean, one question I see getting upvoted is around the frameworks and tools and patterns. So you talked about how we're still pretty early. We're like JavaScript, HTML, CSS. Um, are there any patterns you feel bullish on? Right. I know some folks talk about like state machines and graphs. I don't know personally if that's sort of the angle I want to pursue, but like, do you feel like there's an early jQuery that exists for building out these systems?
Yeah, we actually have our own framework that we build ourselves and maintain ourselves internally here at Cognition. Um, Lots of parts of it that we throw out over time, lots of parts of it that we keep. I'd say my favorite things about our thing, one is a framework that is naturally cache aware. Um,
Mm,
Long even before APIs introduced caching, you actually could get caching effects if you worked directly with the labs and were kind of careful about how you send your prompts. Um, and so that was a lot of like things we had to do and figure out early on here at Cognition to get our agents to work is like how can we get caching even before cache pricing was a part of the API. And so our system has been built with caching kind of like being a very core condition. So even as you scale out and do these sub agents and things like that, having a system that still manages to like optimally cache work from before,
right.
I think is going to be an important thing, just like practically for a developer. I think another part of it is just how integrated is your agent building code with your eval system.
Yep.
Um, and so I think we should put out a blog post about this sometime, and because we take this kind of interesting approach where um, we kind of like segment functionalities of our system into modules, and these modules are tagged in such a way that not only are things that go through those modules things that like we can track and feed into eval systems. When we change code inside these modules, we can then also like back run them against evals from before. And this is just super helpful for developers of being able to like think about your evaling your code in conjunction with your prompts. Um, and and that way like you can completely re-architect some parts of these and still trust your evals from before.
Yeah, that makes sense. In the search space, I've definitely seen examples where like the search system they're using to evaluate the code is actually not the one they're running in production, and then this drift over time becomes like a bunch of massive tech debt.
Yeah.
I know some companies use their own proprietary like prompting templating tools, and because they were trying to be too smart with the prompt optimization, when caching came out, they weren't able to benefit from that because they were doing like dynamic truncation of all these aspects. But yeah, I think being cache aware is something people have not been thinking about too much. I mean, given that, doesn't it also feel like if I do spin up a sub agent, I'm almost better off just copying the entire history, because that at least is cache. Where if I try to summarize it, that breaks. But maybe this is a poor assumption.
Yeah, exactly. I mean, the context passing is like super important for not just for all the intelligence we talked about, but also for caching. Yeah, so like you actually like don't lose that much cost wise if you just like keep the subagent's context around. The main thing I think is probably like the token limit that is what you often run into.
That makes sense. I think a bunch of folks are really curious about this confidence metric. Like I'm pretty familiar with it. It's just like every time I tag Devin on a pull request, there's like the red, yellow, green circle. How is that? Like, can you talk a little bit more about how that has been designed, or how do you get feedback for something like that?
Yeah. We basically we want it to be something that the user can actually trust. So you might see that it actually rarely outputs like a very strong green. And we kind of like purposely bias it to like be very concerned about what it's missing. And so there are lots of specific things we make sure the agent tries to take into consideration when giving a confidence score, including what code have you not seen. Actually, this is probably like the biggest gap. I talked about this earlier already in terms of like the idea of like escalating to a user.
Yeah.
But if you think about how these systems are trained, um, before we started doing RL on agents, they were trained as chatbots, and the chatbots metric is like next token prediction. Can you predict the answer that the user wants or what the correct answer is? You don't get points for saying I don't know, right? Because you output the right answer, you output the wrong answer. When you get it right, you get points. It makes me think a little bit about how some math competitions, what they'll actually do is they'll give you points for just like leaving no answer. And the way it's set up is that you actually, if you have no idea what the answer is and you have some like random expected value of like guessing the right answer, your expected value is higher if you just say like no answer. And I think that's kind of like where we want to make our agents go is it is a lot more helpful for the agent to say, I don't know, or I'm only this percent confident, rather than just saying like, oh, okay, like, here's what my first guess would be for the answer. We also integrate this with our planning so that if it's also really unconfident, it'll just stop and it'll just make sure, okay, I can't proceed until I actually get these answers from the user.
That makes sense. That makes sense. I know we probably only have like 12 more minutes left. I'm going to ask a very selfish question, which is I now find myself mostly just like tagging coding agents on GitHub and reviewing PRs. I'm curious, like, have you guys thought of a little bit more about what that review process looks like and how it can be different in maybe a year or 2 years from now, when I think, I would be surprised that like 80% of the code I write is AI generated.
Yeah, I think there's actually a lot of room for classical frameworks here. I am amazed all the time how much agents are able to just basically build on top of systems that we've built for humans. Like, I mean, there's kind of this joke that like, okay, like, agents are just about like, you fork VS Code, you fork Playwright, you fork, the language servers, and you just kind of just like take all these classical tools that people have been built before, and give them to your coding agent, and it's able to be massively successful. But there are areas where the classical tools haven't filled all the gaps. you need. I think one thing is basically in code review. And if you use Vercel has this really nice feature where you can get like preview links of a site you deploy. And that is great for us because it means that, okay, I tag Devin on Slack, I go away, I do my thing. And first of all, I always told Devin to send me a screenshot of the visual changes it makes. So I don't have to even leave Slack. I will immediately see a screenshot of like, okay, is this even something reasonable that I want to review? And if it is, then I just go to GitHub. I see the preview link that Vercel created. I just click that and I'll just like play around with the site directly. It is like, how can you really like minimize the amount of work you have to do to know whether or not the changes are correct or not? And I think that Vercel preview pattern is something that should probably also exist for backends, for like more complicated systems as well. But the infrastructure to build those things out isn't something people have heavily invested in yet. I think maybe we will have to invest more into that.
That makes sense. That makes sense. Yeah, in previous companies I've worked with, we would always just do like a, 0.5% shadow your traffic to this new endpoint to see if it works. Maybe Devin will just be able to look at those logs and say, okay, these are the error messages. Let me fix those and continue there. I guess now that we only have like 10 minutes left, I'm curious, like, what do you think is something folks aren't really asking when it comes to designing these systems?
Yeah, that's a great question. I think that if I had to guess like how builders are thinking about building their agents from the start, one thing that people often maybe ask too much is about like tool use and the set of tools you give the agent. I personally like to just like give our agent the most universal tools possible and make sure there's very easy to use. So the shell command, like the bash tool, for example, is so fucking powerful. It like literally means like anything you can do on a computer, like your agent can do now because it has this command. Now, it also means that you can actually kind of get around the need for things like MCP integrations for a lot of things because it means that an MCP integration can be reduced to a shell command and an API key, right? You can actually, a lot of times I've seen people build CLI tools that are actually sometimes more powerful than MCP.
Yep, that's exactly what I do.
Yeah. The thing the CLI tool can actually do for you is it can like every time you interact with it, it can like kind of reprompt the agent if you want to be creative in that way. So I found someone who like he was using Devin to work on like this massive test suite, like thousands of tests. And the process he created actually was he created a CLI tool that when Devin runs it, it'll run the test. It'll surface only the first failing test for Devin to focus on. And it'll also manage the git state for Devin so that if Devin like kind of like is working on a test but then messes up something really badly and like earlier tests are failing now, it'll say like, okay, here's like the history of your things and which things were working and now you've made it worse. Do you want to roll back and things like that? And in this case, the CLI tool is like it is doing much more than like what any like MCP integration could do because it's actually interacting with the agent. It's almost like reprompting it. It's to the point where it's almost a part of like the agentic system itself. It's very interesting.
Yeah, I've built some CLI tools to do data analysis. I've been trying to get all these different coding tools to try to basically do data analysis, come with hypotheses, and run new tests. I recently saw someone use Git bisect to figure out when things have been breaking, and it kind of blows my mind that agents can do these kind of things. I mean, I would love to sort of also give you the floor a little bit. I'm curious, like, what are the new things in Devin that you're really excited about, and what are the things you want people to try out?
Yeah, I think the at least related to recent news, the thing that I'm like thinking a lot about now is like where are these like really great synergies between your local development environment and your remote agents that you can use. And I personally think that when you look at kind of like the range of like people in their AI adoption from like the like people just getting started to like the really powerful like power users of AI, one thing that just constantly comes up is just like actually reading code, understanding code, planning how you want to make changes. Because when you're an individual developer, you're actually oftentimes you're working a massive code base, touching code that isn't yours. you're trying to understand it. And when you're trying to work on larger tasks, like you said, like a lot of things you can actually kind of just tag Devin on today and it'll go off and do for you. But there's a cap to that. And like if you want to expand to larger tasks, you have to actually invest time almost in like creating a plan or creating a PRD. And this process actually I think can become easier and easier. It is actually maybe something where like AI has a unique advantage in helping you because the AI, even though it can like only edit code serially, it can read code like so much faster than any of us can. And so I'm very excited about things we're going to be doing and just making that process and experience be a lot easier.
That makes sense. That makes sense. Yeah, in the last couple of minutes, I'm just curious, like, where can we find you? I'll make sure to share some more links on both Devin and your Twitter and anything like that. But yeah, feel free to send off a last message as I find all your information.
Yeah. I'll also drop my email in the chat in case people want to email and ask questions. But yeah, I'm also on Twitter and you can DM me. You know, obviously I try to make this talk as kind of like high level and focused on the engineering of Devin as possible. We spend a lot of time kind of making our agents, really good. I think there's going to be continued lessons we have here. And so I think it's almost the responsibility of like the entire space to just make sure that we're always thinking about like what is going to be the next concept we have to develop in building these agents. And I just imagine like 5 years from now, there's going to be like entry level courses in college about like the concepts of
Older agents, yeah.
And that's gonna be a fun world where like everyone understands these concepts. But yeah, we're doing a lot of work towards that. Obviously in the audience, if there are people who are interested in using the tools that we're building or also like working alongside us, would also love for you guys to reach out and try this stuff out.
Awesome. Walden, thank you so much for being here. I feel like, even just thinking about this, like the escalation and this like pump caching aware frameworks, I've realized that, very few practitioners have been motivated to sort of share what they've learned. So I'm really excited to have you here and teach us everything.
Awesome. Well, thank you so much.
Take care, everyone.